Okay, good morning, everybody. I hope you can see my screen here when the pointer is moving. And welcome to this workshop that is held within the European Green Week as a partner event. And this is co-organized by Water Europe Circular Water Vision Leadership Team. And we have here all the members, all the leaders of this team, and by the IWA Resource Recovery from Water Cluster, IWA International Water Association. And here we have the co-chairs that will speak today. Why we have organized together with this workshop? Because we are trying to synergize the efforts towards circular water management and also to boost the interest of European and worldwide policies towards the importance of valorize water, wastewater, and optimize the sustainable circular use. So my name is Francesco Fatone, and I'm a professor at Polytechnic University of Marche, and I'm introducing this workshop as a leader of the Circular Water VLT team and secretary of the International Water Association Resource Recovery from Water Cluster. And today we are going to have a very relevant presentation. I would like to thank at the beginning all the speakers that accepted this invitation, because we were able to put together coordinator of large innovation actions, chairs and co-chairs of IW cluster and Water Europe ambassadors, in order finally to have conclusions that will hopefully be summarized in a short paper that we will then discuss also with the stakeholders and hopefully with the European Commission, as we did also in Ecomondo and other events. So this is the agenda today. I will start with an introduction showing where we are actually and what is the current work plan of Circular Water VLT of Water Europe. Then we will hear from Olaf van der Kolk, and he is the co-chair of IW Resource Recovery from Water Cluster, and he will present success and failure factors of more than 100 innovation projects that we're working on the valorization of wastewater. Olaf is also the CEO of Aqua Minerals, so he is representing also the business that can be associated to the innovation that we are developing. After that, we will have Ilya Picard. Ilya is a professor at the University of Queensland in Australia, and he has been also the secretary of the Resource Recovery from Water Cluster. So he will present what the cluster is doing, what we can do together with Water Europe in synergy. Then Gerard van den Berg from KWR, Netherlands, and he's also one of the leaders of the Circular Water VLT. He will present the ultimate project that is addressing the water smart urban industrial symbiosis, where of course circular management is one of the main objectives, but also challenges. Then we will move to the assessment part, starting with Evina Katsu. She's professor at Brunel University of London, involved as a leader in circular water VLT, and she will talk about circularity indicators, a very relevant point, especially now that we are connecting green finance and sustainability, circularity. Then we will hear from two very important projects that are addressing mobile chemicals, for example, PFAS, but not only. And the two coordinators, well, the coordinator and the co-coordinator, Julie Lyons, she's coordinating Prometheus from RGM France, and Joseph Klinger will present 0PM. So these two projects were funded within the Green Deal call, and now as a sister project will synergize efforts to address these challenges. And finally, we will talk about digitalization that is supporting the implementation of water smart circular economy with Christos Makropoulos, that is professor at National Technical University of Athens, and will present the digital marketplace that has been developed within a few Horizon projects, such as NextGen, for example. So some information, please pose your questions in the chat. We will have a couple of minutes for burning questions after the presentations. And if possible, we will have also a final session on question and answers. But the speakers will answer your questions soon after the presentations in order to have immediate feedback and discussion. Another information for people that have just joined us, the meeting is recorded and the registration will be also available in YouTube because we are in parallel with other events within the Green Week, and this will increase the audience and people that have asked to join, but they could not because they are in other events in the same morning. So let's start with some introduction, some framework that will hopefully guide us towards the challenges that we have to address. The contents of this introduction are about the EU-funded eco-innovation that were funded and implemented over the last 5 to 6 years. And then we are going to present also what is connected with circular economy and circular water, the nexus. We talk about WEF, WEF, water energy nexus. So we will see how circular economy can be seen as a integration or a subgroup of nexus. But anyway, the two things have to be addressed together for sure. Then we will see how the EU policy context in the water sector is developing and how we were able to influence this development. And finally, we will talk about the secure water VLT and what we are planning to implement in the coming 2 years in synergy with the IW resource recovery from water cluster that will be then presented by Olaf van der Kolk and Ilya Picard. So very quickly, a lot of projects have been funded in Horizon 2020, in the Green Deal Call, and now in Horizon Europe about resource recovery from water. This was presented a lot of times, but the point is that hundreds of millions were invested to fund demonstrations, to fund even first full-scale applications for materials recovery, for energy recovery, for safe water use. And this huge investment has been also recently analyzed in terms of impact. For example, this Impact SC5 that has been funded also within Horizon 2020 was analyzing the Societal Challenge 5 projects to analyze the scientific, societal and environmental and economic impact. So not only in terms of technological development, but also in terms of new jobs, in terms of public engagement, in terms of policy priorities, how these were influenced or addressed. Well, finally, the results of this analysis was quite positive, but still, if we consider the Circular Economy Action Plan, we will see that the role of water, the direct role of water, is not what can be connected to the results of these many projects have been funded. So we can see that a lot of interest is in the role of water within the Integrated Nutrient Management Plan. And we have an attention about the revision of the Directive on Sewage Sludge and the revision of the Directive on Urban Wastewater Treatment and water use. But still, the value that is in water does not seem to be well supported by the Circular Economy Action Plan. Of course, we have a lot of transversal points in the Circular Economy Action Plan that can be well related to the water sector. For example, the promotion of the EU Environmental Technology Verification Scheme, a certification mark or other, but still we think that water is not that central. Very recently, in March 2022, the GRC published the report about work that was supporting the implementation of the Circular Economy Action Plan and the Waste Framework Directive to identify a list of priority waste or byproduct streams and deriving the most suitable candidate for which the EU-wide end of waste or byproduct criteria can be developed. You can see here the link of this report. And after this scoping analysis, you can see that materials that can be recovered from wastewater are not considered as a priority. Well, this was, of course, coming from the opinion of many stakeholders, and it's also acceptable that in terms of quantity, if we compare the water sector with other waste sector or other sectors, the quantities cannot be that relevant. But this is an important point to be considered. So probably we have to work much more at the national level because end of waste is still a major challenge. And after this report, although there is some interest for some material, for example, the biopolymers, still this is not a main priority. So again, water and circular water is a good concept, has been demonstrated, but does not seem a priority for the EU policy. So this means that technologies are there, social impact has been somehow addressed, but still, even from the last documents, we don't see our results to be considered for the forthcoming activities at European level. So this is probably due to the low legal organization readiness level, because when we consider the pyramid of value that we can have in the water cycle, well, the TRL, technology readiness level of several solutions, is probably close to 7, 8, 9 in some cases. But still today, if we consider the number of cases that are recovering materials and reusing materials from wastewater, for example, or even more from the urban water cycle, well, we have niche market, some relevant market in some countries, but not Europe-wide or worldwide. So this means that still the legal readiness level, the organization readiness level is not higher than 5, 6. So probably that was the challenge that we have not addressed properly. But in connection with the circular water, we have to consider the Nexus challenge. Well, in general, the Nexus has been addressed from different perspectives. Globally, the most well-known is the Nexus connecting water, energy, food, greenhouse gas emissions. And it's clear that this Nexus is highly variable with the changes. If we consider not what we are having with the energy crisis that we are having worldwide, in Europe especially, we will see that this Nexus and the projections that we had up to last year is changed a lot. So when we consider the Nexus and we consider, for example, this interconnection, this is from, again, the JRC, we will see how this complex interconnection have to be considered, if possible, as much as possible, even from the governance. One of the most well-known Nexus that has been addressed recently is the WEFE, Water and Environment, Water, Energy, Food Ecosystem Nexus, where climate change, carbon footprint is anyway included. Now we are thinking how our models that we're trying to support the policy have changed, have not considered, for example, the energy crisis. So from here, we will see how we need to go beyond the water technology and how it's complex to consider different interconnection. This figure is coming from the Nexus Net Cost Action that has started last year, where the Nexus is addressed in terms of water, energy, carbon, food, land systems. And the different interconnection in terms of modeling are already difficult to be considered. Can you imagine in terms of policy and in terms of governance? Even in this case, several projects have been implemented and some other are ongoing, funded also within the Green Deal Call, for example. And within this cost action, we have asked the participants to share the activities on the Nexus, and you have some of them that have provided information. So in this case, hundreds millions funded to provide solutions, to provide knowledge, but still, if we consider what is the activity on water and energy policies, for example, that we are having over these years, and these changes, these policies will be there for decades, then we still see a silo approach. We still see that this nexus approach is sometimes mentioned, but still we have a silo approach in terms of framework directive, but nexus governance is not there. So on the other hand, when we are discussing about a revision of the, for example, the Urban Wastewater Treatment Directive, we see that there is an interest within the carbon footprint, within the energy footprint. So somehow the nexus is considered, but not as a nexus priority. So this is the framework. As a conclusion, we can say that a lot of challenges have to be addressed to provide fit for legislation, I would say, solutions, fit for policy solutions, fit for policy suggestions. We have developed a lot of policy papers, but still these have to be more and more considered in our European, national, or local legislations. What is Water Europe doing? Well, in these weeks, actually, Water Europe is revising the vision. The last vision was published in 2016, and after 5 years, we realized that this vision is old. After the pandemics, the war events, and all these crises, we understood that we need to revise. Still, the challenges are too much water, too polluted water, too less water. But in terms of objectives of the water smart society, probably we have to consider new challenges. And to address these new challenges, Water Europe revised the overall organization by horizontal and vertical leadership teams. And the group that has organized this workshop is the Circular Water, VLT, where the main members have been working in circular water projects, circular economy, industrial symbiosis, and in this workshop you will hear 4 of them. I think Tom is also connected. So over the next 2 years, we are going to work in this direction. What is going to do the Circular Water VLT? Well, we are going to develop strategic recommendation for structuring new strategies to underpin circular models that are enhancing the ability of our society to recover, refine, reuse, repurpose, and capture value from and extending the use life of an ever-increasing range of resources and products, so as to project the European water-connected sectors as global circular economy for runners. So please mute your microphone because we have some background noise. So the challenge is to have water more and more central in circular economy, but what we have realized that still in the European documents, but not only, all our efforts are not considered enough. So this strategy, our work plan, can be summarized in this scheme. We are going to interface with the different working groups within Water Europe, but we are going to interface also globally with the International Water Association, mainly with the resource recovery from water cluster, in order to set these strategies that are considering the nexus, are considering water and climate, water security, water recovery, water and zero pollution, industries, digitalization, in order to have finally a vision that will be ready to be integrated with policy programming that at national and European level will really pave the way for more water in circular economy strategies. So with this, I have introduced the framework of the workshop today, and I think I can give the floor to the next speaker. I don't know if you have any question. If not, I would like to invite Olaf van der Kolk. Olaf is CEO of Aqua Minerals, that is one of pioneeristic experience. I'm still mentioning Aquaminerals as a good example, even in Italy, how we should move to have real business out of our results. And he's also co-chair of the IW Resource Recovery from Water Cluster. So please, Olaf, the floor is yours.
Good, thank you, Francesco, also for this introduction. The coming, let's say, 15 minutes, I want to share research we did as Aquaminerals on success and failure factors on innovation projects. We all, I think, spend a lot of time and money on establishing circular value chains, and it would help us greatly to understand what kind of factors add to the success of these new value chains. But of course, if you want to do that, you need a database, and luckily Aquaminerals is doing this for quite some years now. So that's where we got the data from. So let me start introducing Aquaminerals and so you better understand where it's coming from. Aquaminerals is owned by public entities in the water sector, both drinking water and water authorities. As you maybe know, in the Netherlands, they are separated companies. And our main task is to develop and exploit pathways for residuals coming from water treatment. And in that activities, we are kind of a broker acting between the public and private sector. We have a lot of activities, but to put it shortly, we do research and innovation. I'll come back to that later. Of course, if you supply the market with materials, you need quality control, measuring just chemical quality, other kinds of quality things that are important to the customers. Supply chain management on a daily basis, even hourly basis, connecting supply and demand. Sales and procurement. And procurement is mainly transportation, storage, and processing of the materials. Well, some examples, what are we talking about then? If you soften drinking water, you get calcite pellets. And these are used in glass manufacturing, also in a product for gardening, for consumers. If you de-iron groundwater, you get iron sludge. This is, for instance, used in clay bricks and digesters for sulfur control. Struvite, coming from municipal wastewater treatment, which is a phosphorus mineral, is used for pond fertilizer and also in agriculture as a phosphorus fertilizer. These are just some examples. If you want to learn more about that, on our site there's an inspiration booklet with some 30 examples of mature value chains of materials recovered from water treatment. People who know me know that I also like to show a graph. This is the one. This is showing the financial impact. In green is the volume. In this case, it's a graph for calcite. And in red are the costs for mainly transportation. And an important line is the blue line, giving the value per ton, which increased over the period, as you can see, from 2010 onwards. It has a positive economic value. 2014, it crossed the cost line, meaning that from that moment on, the water companies, in this case the drinking water companies, actually made money on this. But also you see the horizontal line, it cost a lot of time and a lot of innovation projects. That brings me to the NextGen project, because the research we did was done within the NextGen project, which is a Horizon 2020 program of the European Union. The most important goal is to design and demonstrate water embedded resources. We looked into depth into 10 demo cases all across the continent. And we looked at water, energy, and materials. Some cases had only water recovery, some had all three of them. And when we started the NextGen, these projects were already beyond the research phase. We had already some data. Important, and it was shown also by Francesco, important is the engaging of citizens, stakeholders, social and governance issues. But our focus was mainly on business models. Where possible, we supported projects. There was a marketplace established, and we as Aquaminerals looked at the business models itself. Later on, Christos will explain more about the marketplace. I would like to go further into the business models. What we did is within this framework of these business models is describing just objectively the different business models within these 10 demo cases. We also described the situation pro and post next-gen solution in terms of money, in terms of carbon footprint, excuse me for the typo, and the partners. If you change from a linear business model to a circular business model, chances are that also the stakeholders in the chain will change. At this moment, we're still doing a research project on successful chains, also beyond the next gen models and the demo cases, sorry. And what we do is describe the roles within the circular solution. We describe the concrete companies and profile each company. And the thought behind that is if we understand what companies, which typical companies are active in circular value chains, we know when we want to establish a new one, what kind of companies we want to involve. For instance, are these multinationals or are these family-owned companies? Big companies, small companies. But this project is still on the way. And we also, and this project is already finished, is a research on the success and failure factors. If you want to learn more about the projects within the next gen, you can go to the site. But as I said, I want to discuss with you the success and failure factors. So what we did is we looked at 100 projects we did over the last 10 years as Aker Minerals. And per project, we did an extensive characterization of the project. Placing the ounce of matrix, if it was subsidized or not, if the market was involved in terms of money or knowledge, and so on. We then decided if a project was successful or not. And you can look at success factors, but also it is important to understand where, when and why a project fails. So what we did is interview a lot of people involved in these kind of projects and asked them what they thought could be a fail factor. So that gave us a long list. I will come back to that later, how we used that long list. So if I go to the results, we found that about 61% of the project was successful or partly successful. I must confess that is a little bit subjective, but we try to be as consequent in our conclusions as we could be. So the 61% doesn't tell us the whole story, or doesn't lead to conclusion, but it's the variation around this 61%. And if you looked at the projects having a success rate higher than 61%, there were projects that involved market penetration, meaning that we try to further develop an already existing product in an existing market, which is not surprising because the theory, this is based on Ansoff, for the people who know something about marketing, also says that if you have an existing product on an existing market, the chances are that you are more successful than other cases. Also not surprising, we found that projects with a high TRL level led to actual successful projects supplying the market with these materials. It's also not surprising. We also found that if we involve the market with money, paying also for the project and also supplying us with knowledge, led to a higher success rate than the 61%. Another one, and that was more surprising to me, to be honest, is that we found, and we also looked at what kind of company was not the actual driver within the project. And we found that if a partner involved with a significant number of employees also leads to a higher success rate. If you would ask me before this project, I would say that mostly the smaller companies would be adding to the success rate. What we saw that projects with a success rate around 61% had no difference if the project was planned or spontaneously. You can plan a project way ahead, partners that you invite, have a planning in time, or on the other hand, a call that you get from from somebody, from a research company, or somebody who wants to use a material or energy, whatever. It didn't really matter if it's in the success rate. What we also saw is that around 61% were projects that involved product development, meaning that the market already existed, but we introduced a new product. We also saw that it didn't really matter if the end user was involved or not. That was also a little bit surprising to me. To give you an example, Aquaminal supplies calcite to a company called Target that makes carpet tiles. As I saw in the previous sheet, it was important that a company like Target is involved in the innovation project, but not the end user, not the people who buy the actual carpet tile. So it's, I think, important for all of us to understand that you find the right stakeholder in the value chain to work with. We also found that it didn't really matter if a project is subsidized or not. And mind you, it's important to understand that doesn't mean that it's not important that a project is subsidized or not, because subsidized project led to a 61% success rate. Yeah? And also we saw that drinking water residuals didn't add to the success rate. Also important to understand what kind of projects are less successful than average. Well, projects that involved market development. Apparently, it's more difficult when we also have to develop the market with an existing product. Also, we see that there are a lot of projects that are enforced by the supplier, by the water entity, so to say, meaning a supply-driven material. For instance, if there's a new technology or the supplier really wants to have the residual applied in a certain economic sector, that leads to a lower than average success rate. And also materials from municipal wastewater are more difficult to bring to the market and have a less success rate. And we also looked at fail factors. And as I said, we have a long list of fail factors, and then we had a list of projects that failed or partly failed. And we went back to the project managers that were manager of the project that failed in its last 10 years. And we asked them to give points based on this long list to factors, the fail factors. And what we saw by far, the number one is the really number one by far, is that they saw that when the technology is not developed enough, leads to possible failure. Also, again, it's not surprisingly, but it's good to understand that manage expectations that if the technology is not developed enough, that chances are that it fails. What we also saw is that during the project, and it can be a project of 1 year to let's say 3 or 4 years, that the market that was involved in the project then chooses for the linear resource because they see that there's a maybe a technology problem, legal issue, end of waste status, whatever reasons they said too much problems, we choose the linear resource. What we also saw is that sometimes a project can be successful, but that we see that there's not enough material to create a successful value chain, because the investment that is involved for processing the material or the user needs a lot more than the sector can supply, leads to failure of the project. And not surprising to you, I think a lot of researchers are here today, that there are some questions after the project, and you need extra funding, and in some cases these fundings were not available, so leading to a successful project. So how we are going to use these results? Well, first of all, we share this with the European Commission, and it can help them to establish more targeted policy, and knowing what kind of projects have a bigger success rate than others. it makes them help them policy making. But also for Aker Minerals and partners, and hopefully also for you, it helps us having a tool for prioritizing projects. There's a long list of projects each year that Aker Minerals has, and understanding what kind of projects leads to a high success rate will probably makes us choose for those projects instead of the ones that have a possible lower success rate. But if there's a project that we think is very important, not because strategically or whatever reason, we might understand if it's placed in the hands of matrix, or we understand that we need more market entities involved. It helps us optimizing the projects, knowing if we add some issues to the project, we can increase the success rate of the project. So this is a very helpful tool for us for the future of the projects. That leads me to my last sheet. As a more general comment, I think, and also the recent problems in the East, recent problems in supply chains from the East that are causing a lot of problems. We need to go to a circular economy, or at least a more circular economy. And let us all be and stay energetic and persistent and do the right thing. And both individually, but also in a holistic perspective, and working together on that. Thank you for your attention, and maybe there are some questions if there's still some time, Francesco.
Thank you very much, Olaf. This was a very interesting assessment, actually, of the activities that were carried out recently. We have a question from Gerard in chat. Is there a specific reason why products from municipal wastewater are less successful in the market? Is this related to sites, interest, quality issues?
Yes, it has everything to do indeed with it. It's are in general more difficult materials to valorize. So they potentially also have more pollutants, pathogens. Also, the legal perspective is more difficult. The end of waste status, and also the market is a little bit more reluctant to use those kind of materials based on these problems compared to drinking water residuals, which are in general more, say, more clean, that don't contain these. So it's more difficult. There are more obstacles for these. A lot of my conclusions are open doors, but it's really good to have them listed. So
yeah. I might have a couple of questions if there is no further question from participants. One is, what is your opinion about the impact of this JRC conclusion? I mean, products from water, wastewater are not a priority at EU level, but end of waste is a major challenge we are really discussing over the last more than 10 years. So the European Commission is not going to work as a priority on these products. Yeah. What do we have to do? What is your opinion? What can be the strategy that the water has to do?
I also heard about this. It's surprising, of course, and a little bit frustrating with all the work that we've done. But to be honest, I can understand if you look at the volume and the impact that the water sector and the recovered materials are relatively small. So this is not the way. If you want to have it on the board tables more persistent, then it's not. But I think we have a lot of good examples. And as a sector, we are very cooperative, as we do today, and on national level. So what we can show the European Commission are the good examples. And I think that's the way to go, and then get it back on the table. Because a lot of economic sectors are, I think, way ahead, we are way ahead on a lot of other economic sectors. That might help, Francesco, showing that a lot of work is done, all the projects you just showed, concrete examples.
Yeah, we have to keep going because we did it for years, and we have to keep going. We have another question from Christos. We are saying that, you can also read the chat if you want. We are saying that if there is no market yet, or we don't have a product in it, or both, this decreases chances of success. Logical, of course, but of course, the entire idea of a circular economy is the creation of new market and products. Any advice on success factors for this early stage uptake? If the question is not clear, you can.
Yeah. So, that's, okay. Yeah, I would. I have to go into that in the research we did, but I think it's really important to increase the uptake, to increase the success factor, is to involve as much stakeholders in this circular value chain as possible. So the research companies, the suppliers, because it's not just supplying. You probably also have to do something on the quality of the material that you recover, but also the end user or the manufacturer involved, understanding how they need it, when they need it, how it should be supplied in an early stage as possible. So also on lower TRL levels.
Thanks, Olaf.
Just a follow-up from what I got from your very interesting presentation, Olaf. Another key message is that from the various potential stakeholders, starting from the end user and going upwards, let's say, it's important to choose the correct ones, let's say, or the critical ones, not necessarily the whole chain down to the consumer, but I thought that was very interesting.
That's very, and the next research project, and it will be presented next week in Barcelona within the NextGen project, is indeed looking at what kind of typical companies, DNA of the companies that are involved in circular value chains, and also how these companies have their governance structure in order. So what we found in the literature, to give you things that we looked in, is that if managers are judged on their performance, not just on money, but also on circular objectives, those companies you will find them more in these value chains than others. So if you set up a new value chain, if you ask a company, do you want to be involved in my new research project, and you ask them the second question, are your managers in, then you probably have the good, and there are of course a lot of more things that we looked in, but just an example.
That's a very good point. This early stage uptake sometimes is discussed within companies only by the innovation department, and you don't get the CEOs, the top managers on this discussion. So the step from the beginning to early stage to real market has to engage the top manager of the operation, for example, and this is missing in many of our projects. We are discussing with the innovation department, but we still miss the main business. Also only discussing. But we have another important question from Keith Rost. You can read the chat, Olaf, if you want. Thanks for the presentation. I understand that high TRL has high success rate, but you also mentioned that technology is very important. So also development of new technologies is needed for further success. And research development cooperation is well.
We just discussed that, yes. So I think also if you picture the technology that you want to develop further, to picture how should it work in like 5 years and who will be involved then, and involve those companies, entities, research institutes in an early stage is very important in my opinion. Yeah, and also getting the right ones, because if you choose the wrong one, so you think, okay, I need a company X to bring it to the market or to process it, but you choose the wrong one, you lose like 3 years. So there's not only the typical companies that you need to involve, but also with the right attitude or the right governance structure to be successful. Yes, I agree. Yeah.
Thanks a lot, Olaf. And that was also a very good discussion. So we can now still stay in the IW resource recovery from water cluster and move to Ilya Picard. So we're going to Australia, but the speaker is Dutch, so we have a European Australian talk now. So Ilya, you with us?
Yeah.
Yes.
Try to share. Is it okay?
Perfect.
Okay. First of all, thanks a lot for this opportunity to present. So I'm going to talk about the International Watershed Cluster for Resource Recovery. So what are we doing? Why are we there? What are our objectives and our activities? So I think Olaf borderline made part of my presentation obsolete, because I think he clearly identified the reasons why we need to have a cluster for resource recovery, but I will do my best to add some additional information. So why did the IWA decided we need a cluster for resource recovery? It was founded in 2014 by the famous Professor Willy Verstraeten. So you can imagine he had some good and convincing arguments why it would be important for the IWA. Some key points here of that initial thought and discussion. So yeah, kicking in an open door, but the ambition of governments to transition to circular economy has been firmly anchored in various policies and guidelines. If I talk here about Australia, they want to...
Olaf.
Sorry?
Sorry, mute your microphone. You're not speaking. Thank you.
Okay.
Just go ahead.
I was worried she was doing okay. So when I talk about Australia here, and they don't pinpoint me on the year, but I think in 2030, 2035, they want to recover 80% of the resources. So that's more like government, the governments, but also within the IWA, the circular economy and resource recovery has become a key strategic pillar. And then plenty of resources that can be recovered from water, of course, can be profitable financially, environmental impact. And this was written a couple of years ago, the future of the water sector, climate change, that's nothing new, there resource scarcity. But in the recent events, you can imagine that, yeah, the water sector is evolving, and now with the crisis, fertilizer prices, natural gas prices, certain resource recovery activities have become way more economically attractive. And then also from an inspiration point of view, the idea was and is that the water sector should be an innovating and trend-setting sector. So we often forget that, in the 20th century, wastewater treatment, well, you treat the water to remove pollutants, has and was actually seen as one of the greatest medical inventions actually in the world, protecting human health. And we still need to do that, but now we have the additional point, inspiration to do that, maybe even in a better way, while recovering the resources that we have. Then there was more the general thoughts of why within the IWA. So why is it important for the IWA? Well, the IWA, they have a lot of specialist groups, and a lot of these specialist groups are somehow working or related to, affected by, whatever name you want to give it to, by resource recovery from water. So the job as the cluster is to really act as a connector between the different sectors of the specialist groups. I think Olaf made it very clear that if you talk about resource recovery, it goes way beyond technology alone. And the specialist groups are specialist groups, more focused on the technology in many of these specialist groups. So it makes sense that there's a connector, an overarching cluster that works together with these different specialist groups. Now, that's not our only task. Our job is also to act as a global network, a connector, a binder, a lubricant. Try to showcase that with these figures here, but it is very important. The IWA is a global institution of organization, and situations change. First of all, we need different expertise, but when you talk about different regions, Olaf and I have brainstormed a lot over the last 2 years. And as an example, between Europe and Australia, the situation in terms of regulation, local requirements, etc., is so much different that it can affect the outcome of a certain project or product or resource recovery technology. So that's really our role. And of course, a lot of things are happening. So it's important as a cluster that we connect with other organizations and share that information and collect information. So that's the reason why we have this cluster. We've put down some overall goals. I think the first one is important to mention is that as an academic or technology provider, you'd like to promote your technology, your research, etc. And it's very hard to stay non-biased, I would argue. Our goal is to promote resource recovery concepts, but they are not our concepts, right? So it's not that we are working as the cluster members on technologies and try to showcase that. No, we showcase concepts done by other people. Doesn't mean we don't do our own research, but I think it's an important aspect to highlight. The second point relates to the external role that we are supposed to play, and I guess Olaf again highlighted very important, very clearly that it's more than technology alone. It's very important which company you work with economic sectors, etc., to establish new and profitable value chains. Yeah, internally, that would be to enable a bigger impact from the work of the relevant specialist groups. Well, we have set forward some objectives. So network, you hear that, you see that word a couple of times. That's important. Bringing technological and non-science aspects. Again, I can relate to the two previous presentations how important that is. We try to bring the team of resource recovery to the company boardrooms. We still have work to do, as highlighted by Francesco, and strengthen the link with complementary organizations. Some other ones out there, and an important one I want to highlight is inspire and educate the next generation of water professionals. And what we do there, or what we did do there, I will show you that in a couple of slides. Then I think this is very important to highlight as well. The traffic light on green or orange on red. So not all projects are successful, not all technologies are successful. And it's actually important to highlight what doesn't work as well and why didn't it work. Was it the technology or the non-technological aspects? And we don't want to reinvent the wheel. I mentioned there's a lot of things going on all over the world, and sometimes it's very nice to say we do something innovative. However, it's already been tested or simultaneously tested at different places in the world. And we talked about resource scarcity. Research, R&D cost money, cost a lot of time. So we don't want to try to reinvent the wheel. I have an example from here. They said we have the first pilot, Anamox pilot, and then you realize, okay, not in the world, in the Southern Hemisphere. But the reality is, it's kind of reinventing the wheel. So I think in these times of day, we really should try to avoid that, learn from each other, and network. And I don't think we do that enough. In academia, we don't have a journal of failures in water, for example. We don't share our failures. No, we share our successes by means of publications. But sometimes it's good to learn from failures or failures, maybe a wrong word, or things that don't work. Okay, then activities. So I mentioned before about educating and preparing the next generation of water professionals. So what we did as a cluster, we developed a textbook on resource recovery from water. Most people within the cluster participated in that, or either edited or wrote or co-authored a chapter. Important little figure on the right, in our opinion, it's open access. So the ebook is open access. The link is, you see it here. I don't know if you can, the slides will be shared or whatever, but if you would like to have the link, you can email me or Francesco or whatever. But it was a big job. It took 3 years, I think. Don't want to go into too much detail, but what we did is basically give a summary of the types of wastewater that we have. Well, we have 3 drinking water, well, that's not the wastewater, but drinking water, municipal wastewater, and industrial wastewater, and really highlight, okay, which resources are in there and how much. Then we focused on established technologies for resource recovery, so focus on the technical aspects, emerging a concept of resources that can be recovered. But then we had a very important section in the book that only focused on economic aspects, regulation, social, and environmental. And we finished with a vision how the water cycle would look in 2050. And we've chosen 4, in our opinion, experts that have been around for a while. And it's interesting to see there's no more roads to Rome, or there's no right or wrong here. Nobody has the views differed to a certain extent. So I think the key message is it's very hard to really predict how it will look like by 2050. So that's the education part. Then our other job is to connect and network. Now, we organize workshops like this one. We did organize webinars, and we are intending to do that again. It's a nice way of reaching a lot of people, much easier in that sense and quicker than writing a textbook. And every 2 years, we organize a resource recovery conference. The last one was the fourth one, was supposed to be in Istanbul, but due to COVID, it was virtual. It was a shame. Would have loved to visit there. And the next one is in next year, and that's going to be in China. So that will be the 5th one. Well, I mentioned that it's good to learn from the past what works or doesn't work, but it's very important that we celebrate success stories. So we have the RWA Resource Recovery Cluster. It's a biannual industry best practice award, which will typically be held during the Resource Recovery Congress and of conference. And here you can see the selection criteria. It's important that that these technologies are implemented at full scale. Then, you probably have seen a slide like this before. What the main resources that we can valorize from the water cycle. So that's nothing new here, but from the cluster perspective, if we look at the conferences that we have organized, so the 4th one, so in the last 8 years, that you really see a change and a diversity. So initially, when you had, or at other conferences where you had sections on resource recovery, there was a lot on water recovery, a lot of biogas, and more and more we see a diversification of research and R&D and at a higher TRL level that has been done. So that's really, really good to see. Of course, we want it to go quicker. I think everybody wants that. But in the bigger schemes of things, it has been a quite rapid change, in my opinion, from an academic perspective. So that's really, really nice to see. Then, so that was what we have done in the past and our objectives, and we try to keep going in the future. So hopefully we connect. One thing I still have to say, I did put the name here of Olaf van der Kolk. So the future is uncertain. So Olaf did an amazing job the last 4 years as a co-chair. And I learned a lot because I have an academic background, and we brainstormed a lot, and then you really see the importance of networking. And when you look at a problem or opportunity from a complete different perspective, basically economic perspective, regulation, all of those things. So thanks a lot, Olaf, for all your efforts. You're a CEO, you're an editor, you wrote part of the book, which is something not many people can say, I think. So thanks a lot for that. And keep up the good work, Francesco, as a secretary. So thanks a lot.
Thanks a lot, Ilya. That was what the IWA is doing in this specific field. And actually, well, that book is a result of a lot of work that has been carried out globally that was really showing how in different parts of the world we have similar challenges. But IWA is a global network, and we see very good results in terms of scientific impact. But the impact that we can have to support policy, for example, probably is underexploited. So my question is, what do you think IWA, resource recovery from water cluster, so let's stay on our field, can do together with Water Europe with the project? So you've heard about several projects about resource recovery. Probably in Australia you have equivalent. We don't have to reinvent the wheel. So in Australia, in Canada, we have several members from Canada. What do you think the strategy of IWA and Water Europe and project coordinators can be to have a major impact, well, to have more circular water and circular economy strategies? So science is going pretty well, but still implementation, business failure is not. And I like very much the idea of a journal of failures in water. I say, yeah, this would help a lot to avoid more failures. So as co-chair and after these years of experience, what do you think we should do better or more?
Yeah, it's quite hard in the sense that in academia, right? It's not in your best interest to say what you were not the first one, right? Or what you do is not that innovative. It's been done elsewhere, right? Because then you might not get the project. Sounds really bad, but so that's not the. It's not in the interest, and in many cases also that you don't know what's happening in the US, right? For example, if you are in Australia or in Europe, you need to have that network. For utility, I would argue they do it I talk to some utilities now. They do that. They talk. The utilities talk with each other, so it's not as organized, for example, as what the Aqua Minerals do. To really learn from, okay, this works under this condition, right? And these were the reasons or the bottlenecks that we needed to fix. But you kind of need to have like global network, not a web page or whatever, but where these success stories or technologies are objectively assessed and shared. It's like an e-network or something. Because I know there's a lot of stuff going on in Europe, a lot, but people here the people that need to know it, right, to make the change, that have the power to make decisions, don't necessarily hear that. So we need to reach the people that make the decisions. On the other hand, if you talk about wastewater, I actually went to a site last week and then said, whatever you do, the person in charge at the treatment plant, you need to convince them. Because if they don't want it, they will not tell their boss or the CEO, because at the end of the day, they need to run their treatment system. So I don't know. What do you think, Frasenko? I don't know if I explained it correctly, but
yeah, I got your point. I think the first task that we can have together. I mean, here we have 4 of the representatives here, whether BLT or Water Europe, to try to write a common paper, a common vision between IWA, Resource Recovery from Water Cluster, and Water Europe Circular Water, and to involve also colleagues from North America, South America, to have a few pages and bullet points on which we agree, and this will have much wider, let's say, impact.
And the other thing is, you mentioned that the work that you did on driving policy, for the EU, it's not a high priority yet. Policy is really important. 1974 was the worst year for the Netherlands with soccer because we lost against the Germans. But yeah, it was an important year when they simply said you're not allowed to use chlorine in drinking water treatment. and we have beautiful drinking water, and we don't use chloride. Why? Well, multiple reasons, but the government said, look, you have to do this point. And I think it's similar for Switzerland now, right, with phosphate. They get 10 years to recover it, right? I think within 10 years, everything needs to be recovered, and I'm pretty sure you're going to get there. So to have a better impact on policy formation, I think is critical as well.
So let's have as a task to address this joint activity. And I don't know if we don't have any further question. I copy pasted the link of the book. That is a very good one and is open access in the chat. So you can download it. I really suggest colleagues, this was designed to be of interest for master students, for professionals. You have examples and applications, so it's open. So please use it. Thanks a lot again, Ilya. And we can now move to next speaker. We stay in the Netherlands with Gerard van den Berg. He's coordinating the Ultimate Innovation Action. It is funded within Horizon 2020, where water smart and data symbiosis is demonstrated in several European countries. Please, Gerard. Perfect.
Yes. Yes. I assume you see my screen?
Yes, we can see the screen. Perfect.
So that should work. So thank you, Francesco, for introducing me. First of all, I would like to apologize because I'm not feeling completely 100%, so I may cough a bit here and there. So please accept my apologies for that. So what I will do today, and I hope I can save some time, but I'm not completely sure about it, is to talk about circular water within the water smart urban industrial symbiosis. I think it links very well to all the other presentations as well, and specifically look into the approaches and activities that we perform within the Horizon 2020 project Ultimate. That actually this week is exactly halfway, 24 months of the 48. So we are also getting our first actual results that will help us further define activities within the project and enable us to share results and ideas, for example, with the European Commission. So very briefly, the goal of Ultimate, well, you see it on the screen, it's to create economic value and increased sustainability by introducing circular symbiotic arrangements between industry and water service providers. So we are really looking into symbiotic arrangements between different types of organizations, because we see that so far there have been quite a number of initiatives within industries, for example, that have looked into opportunities to reuse water within their own premises. But we strongly believe that to achieve our goals regarding circularity, we need to think beyond individual organizations and look at these symbiotic arrangements where we look at reuse of water, the exploitation of energy, and the materials recovery. And I think an important conclusion already at the start of the project was that it's not only about technologies. So a lot of discussions on circularity, also in the academic world, focus on new technologies that enable to reuse materials for a certain process, or to potentially put it on the market. Of course, it's very important. It's vital, because without proper technology, we will not be able to reuse water or to produce materials that we can recover and reuse. But it's not the only success factor. The others we are explicitly looking at within the project are the development of digital support tools. These can be for the optimization of the processes, but they can also be to enable and to express the technologies or the approaches towards stakeholders, for example. Very important, was also mentioned before by Olaf and by Ilya as well, valorization schemes, exploitation schemes. How can we actually put our products on the market and give them a value, and find these arrangements between private and public partners, or between private partners to actually valorize the products that we produce. Stakeholder engagement is also seen as crucial for the success of any development, I would say. If the let's say, and that can go as far as the general public. When the general public is not convinced of the quality of a product, for example, the water reused from a wastewater treatment plant, and has concerns about the quality or the potential health effects, we will have a serious issue unless we have the technologies to reuse the water, etc. So that's certainly also an issue that we take seriously within the project. And the final one was also already mentioned, the political and governance context in which we work. So it's two ways, I would say. It's our goal from, for example, IWA cluster or from the Water Europe and from the projects to show what is feasible and show them the successes that we have in our projects that may change their objectives and change the policies and let's say the political belief in these kind of circular concepts. But it's also the other way around. When we have the political context and we have the governance in place, it may be an initiator for organizations, industries, public organizations to invest in circular concepts. Okay, so what we are looking at in Ultimate is we're looking at these three circular systems regarding water reclamation and reuse, regarding exploitation of energy and heat, and recovery of nutrients and materials. And the technologies and the innovations and the experiences that we have, we also try to make them available within this Water Europe marketplace that will be presented later on by Christos. And I would say, as always in the European research project, we are testing, piloting the concepts that we've developed, and in our case, in 9 case studies around Europe, where we are, and I'm aware you cannot read the table, which is also not necessarily needed, is that we have I would say, a huge number of approaches and technologies that we're looking into. And what I find interesting is also that in the different cases that we have, in most of them, we're looking not only at one concept, either water or materials recovery or energy recovery, but in most cases even on to all of them. So I think that's also it's an interesting approach that in our cases industries which can be quite diverse, as in chemical industry, the agri-food industry, the beverages, and also biotech, that there are opportunities and there is interest as well to look into water reuse, materials recovery, and energy recovery. And if you can read it, you will see that in general, our starting point is a TRL 5. So we have a proven technology, and we try to, at the end of the project, to have established successful pilots at the TRL 7 level. Of course, the success of these technologies and approaches still need a further step ahead to actually bring them to a full scale. But I think it's very important that we show within reasonable size or actual size pilots that that these approaches can be successful, looking also at the different aspects like the technologies, but also at the other aspects that I mentioned. So for each of the case studies, if you want to have a further look, we have prepared short videos, I think 2-minute videos for each, where the different technologies are explained also visually, and you can find them on our website that I will show later on. So I would like, I don't have time, of course, to go through all 9 case studies. So I would like to, to start with one, which is, I think, a good example of the complexity of what we're looking at. The complexity, you also see it in the graph. So we have different colors for the different circular systems: blue for water, green for materials, and yellow for energy. And we've tried to show here that they all contribute to the goals for this specific case study. And we're also starting from previous work, so it's not purely an academic exercise here. So very briefly, in this specific case study, we have greenhouses in the Netherlands. We need significant amounts of high quality water. We also need heat because well, we're not a Mediterranean country, and we do want to grow our tomatoes. And on all of these aspects, we have been looking into ways to optimize these systems. In a previous project, we've looked into the water part mainly, where we have developed a system to ensure that the greenhouses can be supplied by enough water during the full year. and especially during the summer months, they can rely on a system of where water has been stored in the subsurface. So that concerns this left part of the system. If we go to ultimate, the additional steps are twofold. First is that, and that's also driven by a legal obligation by the government, that greenhouses are not allowed to their wastewaters to include nutrients and fertilizers and pesticides by in 5 years from now. That there is an interest to increase the use of wastewater, enabling us to reuse the water as well as the nutrients and fertilizers. And the specific technology that we're looking at is electrodialysis, which enables to produce a clean water part and a concentrate that can be used to produce nutrients and fertilizers. Currently, we're in the stage of experimental stage, but our next step is to work this into a pilot. And the other part is the energy part. So I would like to start with this picture on the lower right. That shows that in the Netherlands, for utility buildings and houses, the ATES system, so aquifer thermal energy storage, is well known and applied widely. This is a system in which heat can be stored in the subsurface, which can be used in winter months to heat buildings, and cool water can be used in summer months to for cooling buildings. What we see in the more industrial systems is that there seems to be more potential of high temperature ATES systems, which infiltrate higher temperature water, also in deeper aquifers. Although this is still not completely legally accepted, we are looking into the opportunities and the effects also in different pilots, and within Ultimate we are also building on an investment that's done in this region in developing a combination of high temperature ATES and a geothermal system. I think this is very interesting because it also shows that in order to enable the success and also the payment of these kind of systems, it's often it can be the success may be assured by also building on other investments that are being done in the region. So we so I think that's also how we should look at investments, not only as individual organizations, but also at a broader scale of investments and developments. So another system that I could very briefly mention is the Kalundborg symbiosis plant. That's a well-known system in Denmark that has been around or is being developed over a period of 60 years already. What's interesting is that in the project we are looking at specific to improve specific aspects of this system. And what's also interesting is that in the coming years, this system will be increased in size, or what I understand is doubled in size, and the new industrial plants that will be built are really looking for innovative ways to secure their water energy supply for the future. And I think currently there is a good momentum for let's say Ultimate, but also other projects to show the advantages of new types of innovations and to apply them in these new large-scale investments that are being done in this case, but probably also in the rest of Europe or worldwide. So what we also see in Ultimate is that that we see a potential for reuse and materials recovery, and depending on situations, it will vary, of course. But I think the numbers that we predict or that we expect, they're certainly substantial and can contribute to the success of introducing circularity in our in the water domain. I could go quickly through this. It's I think it's more the expertise of Olaf than mine, but we're also looking in the project into the arrangements, the symbiotic arrangements that will assure that that valorization of our approaches may be successful. And there are different types of arrangements. We could think of partnerships, of co-ownership, of water service providers, of service provision, and finally some general goals that I will I think I've mentioned all of them. Given the time, I will skip this. And I would like to mention one thing is that next week Ultimate will also be present in the Festival of the New European Bauhaus. That's also an initiative by the European Commission. And I think, well, I hope that in this way we can also learn how we can actually share our share our experiences within the development of urban environments in Europe. So of course we are a consortium. This is our website. You can have a look at it. And well, I would like to thank you.
Thanks a lot, Gerard, for the presentation of Ultimate. That is really addressing this urban industrial symbiosis, where sometimes the challenge is the governance. So maybe a question is related to the governance of these schemes, because when you are doing water reuse, I mean, from city to agriculture, somehow the water tariff can consider this need. But when you are doing symbiosis, city industry is quite often an internal agreement, a local agreement, not internal, between the water utility and the specific industry. So it's more difficult to generalize these at European level, to harmonize these experiences. And it is sometimes the challenge. So what is in Denmark, it's difficult to be applied as it is in Italy or in other countries. So what is the activity that in Ultimate or in your experience is needed to cluster this experience and to support the European governance, the national governance, to have more and more urban industrial symbiosis? Otherwise, we have to start all the time from the beginning to think about what to do and how.
Well, first of all, I would like to say that I think there is still a lot to gain. When I look at my experience in for example, in this case study in the Netherlands, I see that for the greenhouses to be interested in such developments of circularity, for example, and reuse, besides that they want to present themselves as a sustainable sector, they are primarily looking at the price. So if it would be cheaper to buy water from a different source, drinking water, that would have their preference. So for us, it's important to show the added value of the approaches that we have, and also try to to give it a value. So and the value could be €1, but it could also be a value in terms of sustainability or security, a secure water supply, for example, which is also very relevant for stakeholders. I see in the greenhouse sector, for example, that they have concerns about continuous water supply. So that's why we have been looking at these ways to temporarily store water in the subsurface, because it's quite a secure environment, natural environment. But it's so they're willing to pay more for the water, at least at this stage, when it covers part of their security. And of course this needs from on the proper level that there is a governance system in place that allows such systems. So I see in many countries there are objections to inject water of a certain quality, and that can be a burden for, or that can reduce the willingness to invest in solutions. And so I agree with what was said before, that it really helps if there are policy guidelines that say, for example, that a certain amount of water should be reused. That helps in making investments.
Probably the way we should work more is on including these solutions as a best available technique in the BAT references, because in BAT references there is a lot about closed loops within the industrial site, but there is not much about the link with the city and urban industrial symbiosis. So as we have to work sector by sector, probably that is something that we should more target, having these good practices, best available technique. So thank you again. I don't know if we have any further question. No, if not, thanks again, Gerard.
Good.
And congratulations for this participation in Bauhaus. That is relevant. Now we move to Evina Katsu. And the main focus is about management assessment. This topic is highly relevant now in connection with the EU taxonomy, with green finance, and the link that we need to have to quantify also what Gerard was mentioning, not only the economic balance and the economic benefits. Thanks, Evina.
Thank you very much, Francesco, and many thanks for the invitation. Can you see my presentation full screen?
Sure, thank you.
Fantastic. Yes, I think that this presentation fits quite well in this stage of the workshop, because we heard very nice examples from the implementation of circular economy solutions in the water sector. So what I would like to present is how we can measure and assess the impact of these circular solutions in the water sectors, and how far we are from the standardized approaches. So just a very brief background about our R&D activities. We are currently a group of 25 researchers with a main focus on wastewater treatment and sustainable resource recovery. But one very important area for us is the development of frameworks for the assessment, monitoring, control, modeling, and optimization of the processes. And here you can see a sample of current, mainly EU-funded projects targeting at the smartification of the water industry and circular economy. So what I would like to do today is to give you an insight on the methodologies and tools that have been developed in different EU-funded projects on measuring circularity in the water sector, and also some first observations on the framework proposed by the new but still draft ISO on measuring and assessing circularity and sustainability. I'm a member of the technical group and the drafting team. So we have seen that there are several projects on circular economy dealing with assessment methodologies and indicator systems. However, what we also show is that the transferability of the developed approaches remains an issue. And this is because of several factors that I'm going to analyze. So the main question I'm trying to address is, do we have the methods and the tools to measure and quantify circularity in water systems? And how far are we from standardized indicators and approaches? In the new ISO, that I would like just to give some insight and definitions, the definition of the system boundaries is a must. So as we see here, the system in focus is what we are going to measure and the time period relevant to the measurement that is related to the lifetime of products or systems. And these boundaries are often set by practical considerations like the availability of information within a region, the operations of an organization within a value chain, and other factors. So the circularity measurement and assessment can be applied to any system level, from product, organization, interorganization, up to regional and global level. Here is the main framework proposed by the new ISO on circular economy that has 3 taxonomy branches representing different parts of the measurement process. So here, as we see in the first pillar, we have the monitoring of circular actions that can be done with indicators that measure the progress of a circular action or combination of actions. For example, reduce, reuse, repair, and so on. In the second pillar, we have the resource flow measurements that is represented by indicators describing resource flows and stocks and their characteristics needed for the circularity measurement. And as we see here in the third, in the third pillar, we have what is related with the sustainability impacts of the circular actions that can be measured with indicators measuring the impact on social, environmental, and economic aspects. Now, the systemic approach of the circularity measurement taxonomy is represented by the horizontal bottom bar in this figure, and the indicators of the circular actions are used to calculate and aggregate the circular aspects of the resource flows between and inside the different systems. And here we have made an effort to translate the 3 ISO taxonomy branches into indicators for circular actions for implementations targeted to water systems. So the first taxonomy branch includes, as we see here, indicators for circular actions that can be further categorized into control variables and performance indicators for the system. The flow measurement indicators are categorized into resource inflows and outflows, water, energy, and economic indicators, and also, of course, waste and emissions are included here. And the flow measurement indicators in the reality quantify the targeted resource circularity implemented by circular actions. And finally, we have the sustainability impact indicators that, as I've mentioned, include social, environmental, and economic impacts and the value creation by the system. Now, the sustainability indicators, it is important to aggregate them using weights that are assigned by the stakeholders, so we bring them on board, resulting in the total value of the system. And all these indicator categories need to be further aggregated into the total circularity level of the system. For the selection of indicators, we should always keep in mind the system level, the system sector that we focus on, the implemented circular actions, the sustainability impacts of the circular actions, and to always provide a meaningful outcome to the interested parties. However, as I mentioned before, measuring and assessing circularity is not always a straightforward process. Here, I have summarized the main challenges. The first, and as it is the case for all the assessment exercises, is on data availability and acquisition. So the indicators can be calculated using either primary or secondary data. Now, according to the ISO, data effectiveness and efficiency play a major role in the data acquisition process. In the case of missing data, we need to evaluate the consequences, and there is a series of actions and models that should be applied. Now, coming to the EU projects, most of the systems implemented are at pilot and demo scale. So in that case, we have one more barrier to overcome during data acquisitions, since primary data are not always available, and we have also to rely on modeling procedures. Let's now discuss specific challenges from 3 Horizon 2020 projects and if the new ISO can address them. The first one is the Hydrusa Horizon 2020, where we wanted to assess circularity of the water, food, energy ecosystem nexus in a system applying combination of nature-based solutions and grey infrastructure in decentralized areas. The main issue we faced here is that circularity measurement and assessment of water systems, it's not very much progressed. The new ISO includes water as one of the main resources for which circularity needs to be investigated, and it states the importance of the natural environment. But now, how to approach circularity, specifically in water systems, considering natural or semi-natural components, is not clear at all. The lack of a methodological approach to deal with complex water systems led us to the development of the multi-sectoral water circularity assessment framework, and we have quite nice publications on this. The application of the framework enabled us to differentiate between benchmark and dynamic circularity assessment, highlighting that the comparison with the baseline, so the benchmark assessment and the approach followed by ISO, is not always enough, as the retrofit system may not operate under its optimum conditions. Also, there might be lurking circularity risks of uncontrollable events. Our dynamic circularity assessment enabled systems optimization from a circularity performance point of view and can be further used to identify mitigation measures. Now I'm coming to the example of the Deep Purple BBI project that uses a combination of municipal waste streams to generate a range of high added value products using an integrated multi-platform biorefinery process. To complete the assessment of this complex biorefinery, an area that must be considered is the system multifunctionality, but also that product generation is influenced by climatic conditions and changes throughout the year, making it a multi-pathway process as well. This project places a lot of emphasis on the added value of products, meaning that process value creation must be explored in detail, which is achieved using indicators to investigate aspects of eco-efficiency, for example. Value creation is again mentioned in the new ISO, but the methods and tools required for the quantification are not clear. In this project, we explored value creation by combining circularity indicators with other sustainability assessment to identify trade-offs for process optimization. We also integrated models for waste treatment to understand the relationships between the different processes, and we used performance baselines to facilitate the quantification of system gains and also the identification of hotspots that require attention. Finally, we are currently in the process to integrate the selected indicators within the process decision support system for dynamic calculation, resulting in the optimization of plant operation from a sustainability and circularity perspective. In the two previous projects, the main focus was to develop a robust methodological framework that considers the nexus, multifunctionality, the end products, the value creation, the different assessment levels, and other parameters. In order now to tackle more practical aspects related to the scaling up challenges, the Water Mining Horizon 2020 opportunity is coming. And here we investigate how the measured and calculated impacts of a pilot system may change after full-scale implementation using future projection scenarios of the system and prospective assessment. For this purpose, the upscaling modeling methodology is integrated in our assessment and includes a material flow analysis of the pilot system, and then we move to the projection of the full-scale scenario, for which we use a combination of participatory approaches, literature modeling, manual calculations, and proxy estimations. At this stage, it is important to identify parameters that are a reference and sensitive at full scale in order to reduce the uncertainty level. Then we perform again the MFA analysis for the full scale scenario, and this time we complete our modeling procedure with sensitivity analysis and assessment as the final steps. So to summarize, the main assessment challenges include, first of all, for the characterization of resource flows in water systems that are required for consistent calculations of circularity indicators, we follow the environmental science perspective to develop a guidance on the true circularity of water and water-related streams. For water systems coupled with nature-based solutions requiring a nexus approach, we have developed the multi-sectoral framework that I described. For water and wastewater systems for multi-product generation, we developed targeted circularity methodologies in accordance with the new ISO. For technologies with low technology readiness level and for the projection of system behavior and circularity performance, we use upscaled and prospective assessment for short, long-term forecasting of circularity and sustainability impact. For lack or delay of primary data, we combine modeling procedures and operational data. For the selection of appropriate and case-specific circularity indicators for water systems, we develop a guidance on how to select circularity and sustainability indicators. And for a meaningful outcome and usability of the circularity indicators, we integrate the selected framework within the DSS for the dynamic calculation, enabling process optimization. Now we would like to continue with a few slides putting more emphasis to the new ISO and how the main principles can be applied to the water systems. Here you can see the new ISO family towards standardization of circular economy. Standardized definitions are provided by the ISO 59004, while standardized methods, equations, and indicators will be provided by the ISO 59020. And also we have 3 additional ISOs focusing on specific circularity aspects, as you see here. The new ISO is developed in a generic form to enable its applicability to manufacturing supply chains. Let's see now how the most common circular actions following the R's hierarchy apply to the generic and the water supply chains in order to investigate the difference. Starting with the refuse of the non-renewable resource by substituting it with renewable or alternative sources in the production side of the chain. In the generic supply chain, the producer can further decide to make a specific product redundant by changing or introducing completely different product that has the same function for the user. In the water supply chain, this option does not exist. Water is the only product that can be regenerated. Here, refuse is implemented by the customer. Reduction is implemented by the producers and distribution systems, for example, reduction of losses, but also from customers, for example, to reduce their needs and consume more consciously. Repair can only be implemented to the manufacturing supply chain. Reuse is more restricted to water and may require source separation, so it depends on the infrastructure in many cases. Remanufacturing does not apply to water supply chain, while recycling is the last resort for the manufacturing supply chain. In water, it enables and unlocks most of the potential actions that can be implemented from the water industry side. Changes in infrastructure and customers' habits and awareness are required as well. To summarize, the new ISO focuses on the manufacturing sector and more specifically to the upstream side of the supply chain. And this is because suppliers and producers are responsible for selecting and selecting the source of their primary and secondary raw materials, as well as for the fate of their products based on its design and specifications. However, the water supply companies, for example, the upstream side of the water supply have most of the time numerous natural, local, physical, and regulatory constraints that restrict source selection of water. Also, water quality changes with the consecutive use. Thus, the fate of water depends on the user and on the local wastewater treatment plant. Now, circularity in water highly depends on the infrastructure and the user awareness. The other issue is that the ISO definitions require characterization of flows in order to be applied in water. The ISO further stresses the importance of the natural environment and ecosystems resilience to circularity, but it is still very unclear how to approach, measure, and assess the related aspects. And this is a very important issue when it comes to water because the natural environment is inherent to water. Although the new ISO considers some aspects related to water circularity, it is evident that it's not developed to capture the water sector. We have discussed these 2 points that require our attention when it comes to circularity of water systems. However, the main values, aims, and challenges concepts in the United Nations standards as provided by the revised Water Europe's vision for water smart societies, Francesco also mentioned this in his presentation, are not considered and represented in the new ISO. Therefore, careful consideration, transferability, and integration of both is needed, ISO and the vision of the water smart societies. To conclude, there is still a lot of work needed in order to translate the ISO principles in the water sector, and this should be always done together with complementary methodologies customized to the water sector. I believe we are in a good way as we have done progress in the development of methodologies and indicators that approach circularity from different angles. And we are trying to do this in line with the new still draft ISO standards. However, a common effort is needed from all of us. Every water-related project includes sustainability components and can contribute to address the common challenges we face. And for sure, collaboration is going to speed up the process towards standardized approaches in the water sector. Here I have just left this slide as a summary of our current focus and activities as a group towards these standardized approaches. And I would like to thank you very much for your attention.
Thanks a lot, Elina. Yeah, this was really full immersion in the ISO, and standardization is the key to have a clear assessment. So I would have a couple of questions, and maybe other can come from the participants. The first one is about DNSH principles. So within the EU taxonomy and the recovery plans, it's needed to assess the do not significant harm principles. There is also some technical guidance from the European Commission, and the circular economy is one of the 6 DNSH principles. Now, the question is, do you think that this ISO standard is going to provide support, clear technical support to this assessment? Because this is needed now. Now we are working on these projects within the national recovery plans. And well, in 2-3 years will be too late. So have you ever worked connecting the ISO and the DNSH principles? This is the question.
Yes, and this is a very important aspect, Francesco. The good thing is that the way that the new ISO is designed and considering the fact that we can decide on the circular actions, on the identification of the main objectives of the assessment, the principles that we want to assess, this can be taken into consideration. As this also, we have done this. So, for example, and as a part of the assessment that we developed in several EU projects, but not only, we have shown the clear connection and which from the indicators that are quantified can also show the impact on the principles. However, the main issue is in terms of how to assess. So even if you have the indicators, how to standardize this. So, for example, how to drive policy from the outcome of this exercise, and this is something that the ISO offers, and that's why it is very important, the translation to the water systems.
Thank you. Well, I think it will be also very important to have the ISO clearly mentioned in the technical guidance. I remember in exam, when we were talking about energy audit in 2014, there was no standard about water sector, and with Ener Water, we developed the standard. We started in 2014. And the standard for energy audit in treatment plants, European standard, was published in January 2021. I can tell you that this was a great achievement for the project to get actually standard 3 years after the end of the project, but it took 7 years. And finally, if we see what the utilities are doing, they're not using that standard. Because their practice is not according to that standard, and it's accepted anyway. So the point is about timing. Yeah.
And this is what I'm also trying to do within this ISO consultation phase, because it is very much focused on product, on the manufacturing processes, but water is a different thing. So actually, even the assessment of the capitals, the natural, the social, the intellectual, the human, the environmental, that are priorities for the water utilities, is not included. So through the definition of the circular actions and bringing water as an example and one very important sector for circularity, it is what we are trying to do now in the new standard.
Excellent. I think that working with Water Europe and Resource Recovery from Water Cluster, this can really help and support, because otherwise the standard will come too late probably for the next generation EU that is ongoing. So that's these years are crucial, and we need to have a standard as soon as possible. Otherwise, all the projects will be already under implementation, will be very difficult. I don't know if you have any further question, but for all the speakers, if you agree, we can to share the presentation. You can send this back to us if you want to revise something or whatever, and then we can share this with the participants. Anyway, the video will be available. So, well, if we don't have any further questions, thanks a lot, Evin, again, and please keep us updated about this work on standardization. This is very important. Thank you.
Thank you.
And well, we can move to next two speakers that are going well. Now we have addressed standardization, and once we talk about standard and the technical quality of the material, risk associated is also considered. And there are two projects that are dealing with mobile chemicals and, of course, as interface, a risk-based approach that are Prometheus and 0PM that were funded within the European Green Deal call. Now we will have Julie Lyons that is going to present the Prometheus project, and after that, Joseph Klinger will present the project at 0PM. The two are sister projects, so they're going to work in synergy in the next years. Thanks, Julie.
Yes, thank you, Francesco. So thank you for inviting me for this presentation. I try to. Okay, that's good. So I'm Julie Lyons. I'm co-coordinator of the H2020 Promises project, and my background is hydrogeology and mainly groundwater quality. So I will present you this overview of the project Promises. But first, I just want to present you the chemicals cluster for the European Green Deal call. That means that these three projects, Scenario, 0PM, and Promises, are funded by this call. And these three projects are in a chemical cluster. And we will collaborate together to address, to reach the expected impact of this call. It was on the topic 8.1, addressing innovative, systematic zero pollution solutions to protect health, environment, and natural resources from persistent and mobile chemicals. And here, the 6 main expected impacts. We will deal with prevention and mitigation solution. We will support decision making. We will try to contribute to achieve a toxic-free environment. We will provide tools to improve risk assessment, support policy and regulatory action, risk communication, and of course, we will support action deriving from the European strategy to minimize the presence of substances such as persistent and mobile chemicals. And for Promises project, we try to address the zero pollution circular economy. We are 27 partners during almost 4 years. So you can see here the logo of each. You will recognize some you probably know very well. So our ambition here is to increase the circularity of resources by overcoming barriers associated with the presence of very persistent, very mobile, and potentially toxic substances in the soil, sediment, water system. We want to contribute to the zero pollution ambition and to contribute to a safe and sustainable circular economy. Of course, we will also address sanitary and toxicological aspect with human health protection. And you can see on this picture the main compounds on which we will work. We choose to address the industrial compounds for the little y. And we will have a main focus on PFAS. We will start with early concern compounds, such as PFOA and PFOS, but we will also address other compounds, and we will target also transformation and degradation byproducts. And in this project, we will address degradation byproducts during recycling technology and removal technology. So why do we choose to address the soil, sediment, water? We consider that this cycle is closely linked, and that these persistent and mobile compounds will spread to the entire environment and to the entire water cycle system. And we have three main resources, natural resources, such as water, soil, and sediment. I think that everybody knows PFAS, but I address here a little illustration. So the PFAS are chemical compounds composed by carbon, but mainly with fluorine. And these carbon fluorine are very persistent and very strong link, and it's very difficult to break these compounds. Then that means that they will persist in the environment, but they also will be very difficult to remove them from these matrices, such as soil, sediment, and water. And PFAS are also largely used in the day-to-day and everyday we use. Industry use it, consumer use it. We use it also in the aqueous firefight foam, sorry. And we will disseminate through the use of this foam, through the release from industry and through the release from municipal wastewater. And at the end, human will be exposed to this PFAS through the use of the consumption of food and water, but also we have release into the air with atmospheric release. So PFAS are everywhere, are persistent and mobile. So it's a problem for a lot of excuse me. Yeah, it's a problem, and it could be a bottleneck for reuse and circular economy, such as they will go through the barriers. So this project is constructed with two pillars: one technological innovation and one second pillar on systematic and circular integration. In the technological innovation, we will address methods and tools, fate, transport, and exposure of these compounds, and technology for removal of these compounds. For the integration, we want to integrate the results of this technological innovation into a decision support framework, which consider resource recovery and water reuse and support chemical management decisions. At the end, we want to translate this result through the society to help and contribute to input a safe circular economy, but also to support future policies and standardization in the EU Green Deal goal. So in this project, we will have 7 case studies. These seven case studies are distributed among 5 circular economy routes. And in this project, we will address the semi-closed water cycles for drinking water supply at urban and catchment scale. We will have demo case on riverbank filtration to produce drinking water from surface water. We will have a wastewater reuse pilot for irrigation in agriculture. We will also address nutrient recovery from sewage sludge, material recovery from dredge sediments, and also the remediation for groundwater and land for a safe reuse in the urban areas. Our expected key results. First of all, we need to improve and to develop new analytical methods and toxicological tools to detect and quantify PFAS and industrial PMTs in water, but also in complex matrices, such as soil sediment, sewage sludge, but also to develop and propose monitoring strategy to support EU regulation. To support guidance for exposure, we will develop toolbox to assess the fate and transport modeling from soil to groundwater, and also we will develop emission model regarding PFAS and industrial PMTs. We will develop and improve toxicity assessments for single substances or groups of PFAS and PMTs to update derivation of health-related indicator values, and also some toxicological tools with specific endpoints specific to these compounds. We will address new approaches for environmental exposure and risk assessment for the 5 circular economy routes we investigate. About technology, we will test and improve cost-efficient and sustainable technology for remediation of PFAS in soil and groundwater, in situ and on-site technology. We will work also on technology to provide PMT-free materials and nutrient recovery. And a block of technology will address the treatment of drinking water sources, wastewater and landfill leachate contaminated with these PFAS and EPMTs. And at the end, as I said before, we want to develop this decision support framework that will be addressed at a multi-stakeholder level. Here an information, and I think that all the participants today will be concerned, and we want to invite you to contribute to this online survey. It was open last week. And it will end at the end of June. It's a survey addressed to stakeholders to collect views and needs regarding persistent, mobile and toxic substances in the circular economy. So I think I'm today in the right place to ask you to contribute to this survey. So I think that we can share the link by email with the list of participants, and maybe you can also, for sure, you can find the link on our website on promises.eu. So we'll be pleased to have your contribution to this survey. So thank you for your attention, and thank you.
Thanks a lot. Thanks, Julie. So I have also shared the link the questionnaire in chat. So I give the floor directly to Joseph, and then we can have a common discussion, because as you mentioned, these projects are sister. The link to the survey is in the chat anyway. Thanks, Joseph.
Thank you, Francesco. I hope you can see everything on the screen.
Yes.
And as Julie mentioned, we are belonging to one of those 3 projects which are funded and were selected within the EU calls Zero Pollution Solutions. Besides the fact that Julie is the coordinator, I'm not the coordinator, I'm just presenting the project today. And I'm also not deeply involved in the project. That's my colleague, Marcel Riegel from TZW, who is involved. But I just want to let you know that the coordinator is NGI Norway. And in total, the runtime of the project takes 5 years. That means it has started in October last year and will last until autumn 26. That means 5-year projects that you do not have that very often. And in total, the amount funded by the European Union is 12 million euro. So having a look on the partners, we are in total 15 different partners, but very scientific driven, and that's very interesting. And it's also very interesting that many partners are in the, let's say, middle or northern part of Europe. The only one is Greece, which is from the southern part, and it's more or less very scientific selected partners. And especially when you look, for instance, from the German side, I know that very well, the UBA, that means the Environmental Agency. This agency is also very active in policy activities on a European level concerning the persistent and mobile toxic substances, especially in the context of the REACH directive. So what is the project philosophy? As already Julie mentioned, it's the toxic-free environment, and the hierarchy is that you have safe and sustainable chemicals, that you minimize and control them, and that you find out if they're already in the environment, how you can eliminate them and how can you remediate them. So that means especially for the PFAS, everyone knows they're since decades in the environment. You can find them almost everywhere, and how to deal with them in future. That means the idea is that you have only those substances in which are not of concern, and only those which are necessary for essential use. But that's also a bright definition. What means essential use? So that's the project philosophy. Following the philosophy, that means prevent, prioritize, and remove. In total, there are 8 different work packages. Of course, it's the project management, then you have the assessment, activities, policy, market transition, and of course, also substance grouping. What can you do? For instance, the PFAS, that's one group, but there are also some other groups which are belonging to the persistent, mobile, and toxic substances. And then carrying out the risk assessment that belongs to prioritize and find at the end, and it's in work package 7, technical solutions. And when we talk about technical solutions that we are in as TZW, I will present that in the next slides further on. But before, again, just to say some words about preventing means stimulate and support policy changes to more effectively tackle substances in the EU spirit, and assist the market transition and prioritize, especially focusing on the PM substances, that means the persistent and mobile substances. And as already mentioned, having demonstration sites, where you can demonstrate how you can remediate those identified persistent and mobile substances. So about what kind of substance we are talking? PFAS, again, it's overlap with, or in addition to the project Julie presented, the short and long-term compounds there. They have different properties. A lot of long-chain PFAS are very toxic. The short-term, not so toxic, but very, very mobile. When you think about trifluoroacetate, You can even find that in the rain. And at the end of the day, it belongs if you have N no 0, that means that's at the end the trifluoroacetate. We have also the triacenes and the triazoles as compounds in regard in this project. So coming to work package 7, finding technical solutions. That means if they are already in the environment, what can you do, especially in respect to drinking water? The first point is, in many cases, you have to find new analytical methods. When you talk about or think about the drinking water directive, there is also PFAS total, for which you do not have yet any analytical methods, but it's already written in the directive. To demonstrate the removal of PM pollution by new technical solutions, and if you have new technical solutions, to evaluate them, and also investigate the fate of persistent and mobile substances during wastewater and sludge treatment, for instance. But we are focusing as TCW, as I mentioned, on water treatment. We have focused different processes, especially hybrid processes. That means granular activated carbon and ion exchange, a combination, especially for PFAS. We'll present that in the next slides. And the second process is enhanced add and desorption from granular activated carbon by polarization, also at the moment not commonly used in drinking water treatment. Well known are dense membranes, and we have also 2 test sites where we can study on full-scale behavior in the water work. And additionally to that, we also can study in the underground the biotransformation, microcosmos studies, and at the end, the technical evaluation of all these ideas. So coming to the treatment process, within the PFAS, I already mentioned there are long chain compounds and short chain compounds. The long chain compounds you can quite easily remove by activated carbon. But you have the short chain compounds which are not easily removed by activated carbon. And the idea is you first have removed the long chain PFAS, and then you remove the short chain PFAS by ion exchange. And if you have at the end, because of the ion exchange, regenerate, that you also have to treat. And the idea there behind is the electrochemical degradation process. First investigation shows that's very it's a tough process. That means at the moment we're thinking if this is really the best solution, but the studies are going on there. And the second process that you use granular activated carbon, you have 2 things in the activated carbon. You have the activated positions, and you have also a certain kind of ion exchange positions in the granular activated carbon. And using this by electrosorption for step 1, and then electrodesorption, that you enhance the behavior of the granular activated carbon concerning adsorption and ion exchange properties for the long chain and the short chain PFAS compounds. So, and these techniques are used in 3 demo sites. They are nearby, 2 are nearby here in the German area, where we are situated in the southern area of Germany. It's called here on the left side, the case study Rastatt. There's a great contamination of the surrounding, and at the moment you will find the PFAS in the groundwater, and the plume is moving towards the waterworks, and the colleagues at the waterworks have already installed first treatment activities and to study them further on. In this case, in the upper Rhine, that means it's in the middle of Germany, we have the bank filtration. That means PMs are directly coming via bank filtration to the waterworks. And we have a third case study. It's in Michelin, it's in Greece, where we also have the application of sludge as fertilizer on the land and then reaching into the the underground. So these are the 3 case studies where we can look on the different techniques, on the different behavior of, at the end, biodegradation processes, and again, as mentioned, concerning the water treatment process, all the things concerning assessment and all the other work packages. All the other colleagues are much more familiar than we or me in this project, and therefore I can kindly ask you to have a look on the website here mentioned concerning the whole project. Again, NGI is the coordinator, and from our side, if you have any further questions after this session, you can contact me, or you can contact directly Marcel Riegel, which is a colleague of mine here at TZW. Yeah, that's it in all, a short presentation of this project, but as I mentioned, it has already started, and we will see where we will be in the next years and at the end in 5 years. So thanks a lot.
Thanks a lot, Julie. Thanks a lot, Joseph. Well, and the PFAS, well, I'm living in Italy, where we are one of the main hotspot about PFAS contamination, at least known hotspot, and in terms of impact on the public, it's really huge. I mean, millions of people have been tested for PFAS concentration in blood, and it's really something that is now on all the means of communication. I mean, usually the environmental issues are not that relevant, but in this case, yes. So my question is about the timing. Even in this case, for example, now we are working on, this is also in the chat written, we are working, the European Commission is working on the European guidelines, for example, for water use risk management plans, and is expected to be published months. On the other hand, these projects and other activities, we have longer activities because we want to produce solid scientific results. So the question is how these projects are going to support this ongoing work that the European Commission is doing that will finish before the end of our projects. So timing are not well aligned. So how can we support, for example, in this case, the guidance for water use with our result that will be partial, probably? I don't know, Julie, for example, can reply, or Joseph. Well, water use and water cycle is of concern in both projects. I'm partnering in Provision, so it's a question also for me. I don't have an answer.
Yeah, you're right. The timing is not very much aligned, but let's say we should take every option we have. I do not have an answer right now, which we see to support the political activities. For instance, when you look on the REACH process, there are activities on introducing PMT properties for the evaluation and especially the behavior of substances during drinking water treatment processes into the evaluation process. This is at the moment ongoing, and every new, let's say, result can positive influence this process.
Okay, and Julie, do you plan any interface with this JRC, for example, to provide input before the publication of this guideline? Otherwise, maybe not. It's never too late, but it will be a bit late. You're muted, Julie.
Sorry. Yes. Yes. In fact, it's. I think it's that this timeline is not new, and it's a long story for every regulation and every guidance. So we can promises won't be able to give results on PFAS before this guidance, but we can propose technology and I would say way of working on this circular economy. So we can put some basis just to start and to take it into account with general recommendation. The reuse is we were speaking in previous presentation about groundwater storage. It's my main field of work. What is the objective is to reinject drinking water in the groundwater? Is it to inject demineralized water in groundwater? What is the request of quality when we want to reuse, and what is the use of the reused water? So we can help with the philosophy, with the okay, we are taking this into account. We are able to evaluate the transfer factor. We will provide tools, and this need to be taken into account. We always have different steps. When a directive is provided, then we have 5-10 years before the guidance methodology is published. So we will be there for the guidance and for the operational support.
Yeah, I think it's important to be there as an annex, let's say, saying that there are these projects that are working. So it's important that when these projects will be ready to support with scientific evidence, this guidance should be updated. So at the moment, it's important to be there clearly mentioned formally, and so this way we can have an interaction, even readdressing our work, although this is not in the grant agreement clearly, and by this way we will be able really to have to reply to questions. So that's why we are stuck in our grant agreement, and maybe the questions are not what we thought 2 years ago. That's for example, you know, if you talk now to water utilities that were concerned about materials recovery, well, they are telling, look, forget about materials. I want to focus only on energy, because the price of energy has increased of 40% for some cases. So they are canceling all the projects about materials recovery to focus on energy. So things are changing quite fast. And if we think about energy intensive processes to remove PFAS, they will tell you, okay, let me do again my calculation. So really, that's the challenge that we have to face to be more resilient to these changes. But we have another question from Ilya or Joseph. Ilya, please.
Yeah, so actually it was more a comment. So in Australia, nothing. Well, we didn't have a lot of research about PFAS, but then suddenly, we have a lot of old army sites and airports, and PFAS became an extremely hot topic, political topic. So we have the Australian Research Council, which something like the EU 2020 EU Horizon. So they provide the research funds, and they also have special research initiatives for very urgent problems, and they are co-funded by industry. In this case, it was the defense, because the Australian defense, I don't know how many sites, old sites we have that are heavily contaminated with PFAS, goes into the groundwater, etc., etc. So this started about 2 years ago, and a lot of projects were funded. And some of the things you presented, in my humble opinion, I shouldn't say it gets to YouTube, but your concept is better than that some projects that we do. That's one point. So again, it's about the sharing, reinventing the wheel. The other thing is, in the US, it has been a problem for a longer period of time, or at least it got more attention. Then the ARC organized a workshop with companies and experts from the US. And I was really amazed about the knowledge, the research, the R&D, the pilots that they have been doing in I don't know how many years. So again, is this comment about there's so many smart people around the world doing amazing things, but somehow we lack the ability to communicate beyond the papers, the conferences, and a conference, I guess, is it's a bit of a snapshot, right? It just only X amount of presentations are accepted, and then you see each other 2 years later or whatever it is. So yeah, that was more comments. So first of all, great work, and secondly, yeah, I don't have the answer, but the workshops like these help and work. But I think there's really a need to have a more interactive and proactive way of sharing beyond just the academic publications.
Thanks. I don't know if Joseph and Julie want to.
Yeah, you're absolutely right. Concerning Australia, we were in close contact to Karen Rose from Water Research Australia, and we are doing a lot also with the colleagues EPA in United States and the Water Research Foundation in the United States. It means that we have we're trying in another group. It's the Global Water Research Coalition to, let's say, to share information. But of course, that doesn't avoid that you sometimes duplicate things. But there are different approaches.
And not everybody knows.
Yeah.
So nowadays, if within a day we know that Johnny Depp drinks mega pints of wine at 10 a.m. in the morning and doesn't hit his wife, but the important things seem somewhere to not shared globally and as widespread as I guess we would like. It's hard, and I don't have the answer, but for me, when I saw it, it's like, oh yeah, this is a clear example of non-technological things and that we should try to improve, not having the answer.
Let's say step by step, try to make the situation better.
I think with this concern, the connection with the IWA cluster, Water Europe, can really help. We have another point from Christos. This is a good point, but probably more a challenge for Christos. I don't know if you want to ask this question directly.
It's not really a question; it's a comment, perhaps. That the question that you posed, so the colleagues responded to, so this mismatch between a regulatory process going on and research, not being ready for every regulatory step. I mean, we face it constantly, as you know, in all sorts of projects, in all sorts of regulations. There's always necessarily a mismatch because these things, are designed and executed in different scales. So it's only by accident or happy accident that this could be aligned. So I think we should really think about addressing this in a more systematic way, not perhaps so much from the point of view of the projects, so speeding up their tests, because that is not always possible. Of course, we will do as much as possible, as Joseph said, but also from the point of the regulations, thinking that a related innovation, let's say, inverted commas, in the regulatory sphere, should be one that makes regulations flexible and adaptable enough to new evidence as it becomes available. And regulations can prescribe outcomes, they can prescribe means, or they can prescribe processes. And some of these, and other things, I'm obviously simplifying, but some of these choices, let's say, at the regulatory level, are more suited to fast-moving, let's say, fields such as this one, so that they can become updated, as they don't prescribe technologies, for example, that in a couple of years' time are not relevant anymore.
Thanks a lot, Christos. So that's another challenge that we somehow we need to standardize this strategy, because this is a problem for all the projects probably. So if we don't have any further question, we are a bit late, but discussion was very good. Thanks a lot, Julie and Joseph, and best of luck to all of us for this challenge to addressing with mobile chemicals. And we stay with Christos for the last presentation. It's going to present a product from NextGen, but also complemented by other products such as Ultimate. That is the digital marketplace to boost solutions. So somehow we are back to the market. We started with Olaf and we are finishing the market expectation. So thanks, Christos.
Indeed. So thank you very much, Francesco. And also good afternoon formally from me to everyone. I know it's a bit of a challenge to deliver the last presentation in such a really inspiring workshop. So I'll try to be as brief as possible. As Francesco said, my name is Christos Makropoulos. I'm a professor of water management and hydroinformatics at the National Technical University of Athens, but I'm also a principal scientist at KWR. And so what I will try to do today is let's say, present our answer to an important question that was raised a few times. Actually, Olaf also raised it in his presentation. I think Ilya also could be part of the point that Ilya made just now about cross-project, let's say, connectivity and more continuous ways of exchanging knowledge, evidence, success stories, and so on. And the question is that, of course, given how much innovation is taking place, like we saw today on the one hand, but also the real needs on the ground from the green transition on the other, how do we ensure the solution providers and problem owners know each other, can collaborate with each other around these innovations and their demonstrations on the ground, beyond, let's say, the limits, the necessary time limits and budget limits of the projects. The answer we came up with, part of the answer, let's say, is that, of course, we need a shared space, shared place, if you like, a marketplace in this case, and that is what I will be talking about today. So in the context of the NextGen project initially, we brainstormed around this issue and decided that what was really missing is let's say, we called it a marketplace for water in the circular economy. And by water, I don't mean only water, I mean water, energy, and materials. So the type of discussion we're having today. And a marketplace that is not dependent on external funding cycles. So it doesn't disappear when projects end, and is able to provide a longer-term connecting service of high added value to both problem owners and solution providers. And we decided that a key entity that can ensure really this longer-term sustainability and enhance visibility of such a marketplace is, of course, Water Europe. So we started developing this marketplace in collaboration with Water Europe and with the explicit aim of hosting it under Water Europe auspices to be available to all relevant parties and stakeholders, obviously well beyond any individual project. Now, during this time, we were fortunate enough to get two other European projects interested and engaged in this effort. One was Be Water Smart, and the other was Ultimate, whose coordinator Herod is with us, of course, here today, and who joined forces with NextGen to develop something that I think is really impressive. And of course, I'll explain more in a minute. But before I do, I just want to emphasize that although the development of this, let's say, infrastructure, the marketplace infrastructure, is a project jointly undertaken by NextGen, Be Water Smart, and Ultimate, of course, with the collaboration, constant collaboration throughout Water Europe, its contents, so the materials in there, is of course open to and updated by a much wider set of relevant projects, including, in our case, as you saw, clusters or projects like water mining, which Dina mentioned, reways or wider uptake, and of course, any other relevant project can also make use of this facility. We heard quite a lot about relevant projects today. So who is this marketplace for? So, well, I mentioned problem owners, so entities such as utilities, industries, but also local and regional authorities that seek solutions to turn linear processes into circular processes. So the people that typically ask the question, has this been successfully applied somewhere else? Which is probably the first question we always get when we pitch an innovation, let's say, to an owner of infrastructure. Now, and of course, the side question is, where can I find more about past experiences on the ground, past applications? Now, within this marketplace, they get to meet, so as problem owners get to meet solution providers, in other words, entities, companies, SMEs, institutes that provide technologies or services as part of a circular economy enabling portfolio. But of course, there are also other stakeholders in this domain, so investors seeking opportunities to maximize investment, regulatory bodies, NGOs, academia, of course, and research, looking for demonstrations of field data or innovation opportunities. Now, you will notice that I have also added two more types of potential users, buyers and sellers of circular economy products. So the types of entities that Aqua Minerals brings together, but I have grayed this out. And this is because currently this type of functionality, so let's say the Amazon of circular economy products functionality, so to speak, where you can actually buy 5 tons of specific circular economy material of specific quality through the marketplace is not supported. Just to note that there are, of course, developments on this type of marketplace as well. So, for example, work we do within the water mining project is relevant here on the specific topic of byproducts of desalination, but this is not the type of exchange that is supported by the Water Europe marketplace. So what is supported? What can users do? They can explore available technologies, tools, products, and services, also using targeted search capabilities. They can showcase successes, so they can add and, of course, look at, on the other side, cases with successful circular economy implementations to find out more about enabling conditions, lessons learned, limitations, transferability, and so on. And of course, they can network. The marketplace brings together potential partners with common interests. It also actively supports face-to-face or online meetings. It supports the organization of events. These events are usually, the default is that these are events under the auspices of Water Europe, like Water Market Europe and so on, and also provides personalized and to-the-point information, so recommendations based on user preferences, interests, supporting by machine learning algorithms trained to suggest interesting entries to users based on past behavior within the marketplace. Now, last but not least, the marketplace encourages innovation. So it supports promotional activities, supports funding of startups. So you can launch a crowdfunding campaign, for example. So let's have a quick look under the hood, as it were. First, we developed a classification system of innovative technologies supporting the circular economy in the domains, of course, of water, energy, nutrients, materials, and produced a taxonomy of technologies. So obviously, a knowledge base of the kind that the marketplace sits on needs a very specific taxonomy of technologies, and you can see part of this at the center of the slide. We then looked carefully at the mechanism through which new technologies can be added by users, thinking, of course, beyond project ends here to ensure a quality and a direct relevance of the content. Now, this is actually very important. Note that this is still about technologies, not products. So, and that is quite important. Things like anaerobic MBRs and so on, rather than a specific product of a specific developer. I'll come on to products, of course. A marketplace does have products. And each technology is included in the marketplace through a specific fact sheet, like this one, which includes relevant information in brief, so from its description to its unique selling points, to links to providers or demo cases. And as I said, by technology here, we mean, let's say, more generic circular economy technologies and innovations, not specific solutions. At this point, this comes later. Cases are also obviously relevant and visualized here. They are registered through their own fact sheets, which include information on where, how, why, but also best practices, requirements, conditions, methodologies, synergies, benefits, costs. Cost is always the second thing that people ask. Has it been applied elsewhere? And then how much does it cost? And of course, cases and technologies are interlinked to allow users to navigate from one to the other seamlessly. So moving from generic technologies to specific products, registered users can promote their products, so tools, services, and so on the marketplace. And I say registered users because up to now, all the things that I said about technologies and cases are really a knowledge base, and therefore it's open to everyone. A registered user can also put things in promote the products, and of course get this customized advice that I talked about. And of course, there is an implication here, a small fee to be defined by Water Europe for this registration to ensure the viability of the marketplace, but of course with certain motivational benefits. For example, an idea is that early adopters will be able to upload their products for free, and note that for products, their owners, I'm bound to have this question, owners are responsible for the content of the product factory. That can't be done in any other way. Now, within the marketplace, products get promoted through, for example, being associated with specific technologies, tags, organizations, through search possibilities, but also suggested by the matching algorithms on registered user dashboards. And we are also thinking of additional promotional concepts such as product of the month, newsletters, and things like that. Now, moving on to another important function of the marketplace, which is networking. This applies again to registered users, of course, and indeed one can search for experts, get connected to them, follow them, or contact them through the marketplace. The marketplace supports this through information that is provided. So information such as affiliations, interests, preferences, and so on, provided by the registered users themselves. So you can select your profile type. Are you a problem owner in search of a solution? Or are you a solution provider in search of a problem? Sometimes we are. And then the recommender system takes up the task to make matches. This is a really advanced algorithm which determines when and where an expert or a product are shown, let's say, in as a recommendation on the dashboard of a user. So people are matched through common interests, for example. Products are matched based on your state preferences or even indirect preferences, so extracted from browsing behavior to make suggestions that are relevant. And indeed, you can modify this by the usual like button functionality that helps the algorithm better understand what you're looking for, what you like, and so on. And perhaps, so this sort of thing, so it's not exactly a like button, but close enough. I think the most important thing to say is that the marketplace is live already. This is the link to it. It already contains a significant number of technologies, tools, and cases. It was launched about a month ago in a major Water Europe event. There are already technologies, tools, cases from the contributing projects. But of course, as I said, the intention is not to limit it to 3 projects, 30, 40 cases, but really expand it. So please feel free to have a look, try out for yourselves. We are still also developing it because NextGen and these other projects are not finished yet. So your feedback in terms of things that you would like to see or things that we should take care of or wishes even for this to be really useful to the community would be really highly appreciated. So as they say, watch, but also, I guess, engage with this space. Thank you very much.
Thanks a lot, Christos. Well, this is really amazing in terms of potential. So I would have a couple of questions. These days there is IFAT in Munich, and I wasn't there regularly, but I've been told from colleagues that it's amazing the number of people that are attending IFAT in Munich. I'm in contact with the Ecomondo, and even Ecomondo is another trade and exhibition fair where the number are increasing like never. And this is the traditional place where exhibitors about environmental are. So there is any connection between this marketplace and these large trade and exhibition fairs already?
So currently no, but the intention is, as you very well know, to expand it to larger audiences. Clearly, there is a Water Europe, let's say, element here in that it is a Water Europe led, not led initiative, because obviously it's an initiative of all of us, but it's an initiative under the auspices of Water Europe. So there is a matter of a link between IFA, the Commondo, and Water Europe as well. But I think this is trivial. And the intention of Water Europe and of the projects is to open it really up and make it available and useful to these larger communities. Because otherwise, what is the point? We would, to put it in another way, we would be very keen to discuss this with you or other people that have ideas about, audiences where and places, physical or not, where this platform could be useful.
Yeah, I have a couple of ideas for sure for the Commondo I can facilitate, but even within IWA, I think we should promote this.
Yes.
Yeah. And well, we have a question from Gerard. Are we going to compete with the new initiatives such as the Horizon Results platform, or other platform? This is a good point.
No. So obviously, the idea here is not to compete. The Horizon Results platform is a very generic platform, and it's of course a great initiative to be able to find all of the information from projects somewhere. But of course, it covers a much wider. It's a catalog, let's say, of everything. The marketplace here is, we hope, a much more alive thing, in that, of course, quite a lot of these technologies and these demonstrations come from projects. So, but the attention here, the marketplace content, is not about deliverables of projects. It is about technologies. It is about demonstrations. It's about lessons learned. It's not about deliverable 7.5. So clearly, there is some link between, a case study in deliverable 7.5, but the marketplace is about, circular economy per se, not the results of projects. I would think that there is a huge potential for synergies here, in that both in registering results in the Horizon Results platform, but also in the marketplace, we can cross-reference each other for interested parties that would like to see also, deliverable 7.5 related to a case they really like and they want to dig deeper and explore. So I think that would be a very big opportunity.
If I may add to this, so this question actually came from the discussion we had this week with European Commission officers. So they have a lot of these initiatives like Horizon Results Booster, Knowledge Valorization Platform, Horizon Results Platform, and so I wondered if we should. So we're now linking it to Water Europe, which I think is excellent. Would we also consider it to link it to the European Commission itself as a platform? Because I don't think we have access to all the water-related projects, results that are developed. Just a question.
So I think there are two questions here. The one is a question of, let's say, ownership, as it were, in the broader sense of the word. As you know, the idea here is to have, let's say, a Water Europe flag on this, because we thought, and I still think, that this is a very good way to ensure sustainability beyond projects. Now, does this mean that we shouldn't